Welcome back. In this class, we are going to give another example on how to establish an iterative method for finding roots of some numbers. So let's demonstrate the example. So establish an iterative formula for cube roots of n, where n is a positive real number and hence evaluate cube root of 12 to nearest 4 significant figures. So this problem is simply testing on the application of Newton-Raphson method. So solution. So we'll say let x be this value of the cube root of n. So this means finding cubing both sides. We get x power 3 equals to n, i.e. x cubed minus n equals to 0. Now I'll call this one equation 1. So then you say from equation 1, we have that f of x is given by x cubed minus n, which means that derivative f prime of x, this will give, remember this is a constant, so we'll have 3x squared. Derivative of minus n is 0. So let's call this pair f and f of f prime of x, let's call them 2. From 2, we have f of xn, so n iterate will be given by following this rule, xn power 3 minus n, and f prime at xn will be given by 3xn squared. So also let's call this pair, let's call it 3. Now from Newton-Raphson method, Newton-Raphson formula or method, xn plus 1 is given by xn minus f of xn divided by f prime of xn. So using 3, let me call this a statement from Newton-Raphson formula, let me call it 4. In 4, we have xn plus 1 equals to xn minus, so the place of f of xn we put xn cubed minus n over 3xn squared. So then what remains is just childish mathematics to simplify this equation to have a common denominator. So xn plus 1 equals to, so LCM is 3xn squared. So this will give us 3xn power 3, so because this over 1, minus xn cubed, and then will be plus n. So which get the same thing as 3xn squared. So this would be 2xn cubed plus n. Now we can write each term under 1 LCM. So we'll have x n plus 1 equals to 2xn cubed over 3xn squared plus n over 3xn squared, which will be 2xn over 3 plus n over 3xn squared. Now this expression here, these two terms have a third extra common factor, so i.e. xn plus 1 is equals to 1 over 3 into 2xn plus n over xn squared. So this is the iterative formula for finding cube root of some given number. So then let's go now under the last part of the problem. So cube root of 12 means that n for this case is 12. Now we know that 1 cubed is given by 1, 2 cubed is given by 8, 3 cubed is given by 27. So which means that cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3. So this means that cube root of 12 should be between cube root of 8 and cube root of 27, because 12 is a number between 8 and 27. So these are what give us perfect cubes, perfect cube roots. So i.e. cube root of 12 lies between 2 and 3. So we pick our initial approximation, x naught, as the average of these extreme values 2 and 3. So this gives us 2.5. So x1 will be given by a third into 2x naught plus our n is 12 divided by x naught squared. This from the formula we have. So this will be the same as a third into 2 times 2.5 plus 12 over 2.5 squared. So we have 2.5. So answer times 2 plus 12 divided by answer squared times 1 over 3. So we get x1 equals to 2.30666666667. x2 will be a third into 2x1 plus 12 over x1 squared, which will be twice answer plus 12 over answer squared times 1 over 3. So that gives us 2.2895569889. And then x3 is a third into 2x2 plus 12 x2 squared, which will be so twice answer plus 12 over answer squared times 1 over 3. So this will be 2.289428.492. So let's see the level, the accuracy for this question was 4 significant figures. So this one to 4 significant figures is 2.28. So 2.90. This will be 2.2. So this will be 2.290. Yes. So this is 2.89. So they are different. So let's go to x3, x4, which will be a third into twice x3 plus 12 over x3 squared, which will be so answer times 2 plus 12 over answer squared times 1 over 3. So this is the 2.29428485. So this will be 2.289. So because this and this are agreeing to the stated level of accuracy, so therefore we say cube root of 12 is approximately 2.289 to nearest 4 significant figures. So that's how we solve it. So you can, in a similar way, find the iterative formulas for finding nth root for a given number n.